Okay, well, you're probably looking at the spreadsheet right now and you're thinking, oh my God, what does he want? There's a lot of blanks in this spreadsheet. What's going to happen? Okay, well, we're going to take it one step at a time, and that's the purpose of this video. This video is going to accompany your laboratory technique and procedure with the laboratory data that you have gathered as you did these titrations with the iron supplement. So what I want to do is take a little bit of time, right? I mean, we have to go into this knowing that some people have never, ever maybe had a science course before. So I want to take some time and give you an opportunity to really flesh out all of the math that's going to get required for the spreadsheet. And if you look at the spreadsheet, there are quite a few blanks that are showing up. Way more than what is in your data sheet that we had you to go through the motions of solving for by hand. All right. So here in the next handful of minutes, however many minutes that it takes, I'm just going to take my time and we're going to talk about each piece of the spreadsheet so you know where this data is coming from and the calculations that go on within the spreadsheet and how to key them in the proper way. Because maybe the calculations are new to you, but maybe fully utilizing Excel to the best of its capabilities so far that you know how to use is going to be a feat within itself. All right, so with that said, without further ado, here is the spreadsheet for the titration of an iron dietary supplement. Now, like we talked about in the lab before or the pre-lab lecture, the dietary supplement world's kind of funny because they don't have to follow some of the strict rules and regulations that medications might have to or over-the-counter medications have to. Dietary supplements can kind of get by with a little bit more than what prescription or OTC drugs can in the grocery stores or at Walmart or Target or at these big box retailers that you might go into to purchase. So it's very curious to figure out, well, the tablets that we use today, these are dietary supplements. They are to support your need for iron. It says 65 milligrams on the label. Is it really 65 milligrams? So when you download this Excel spreadsheet, what you will find out is up here at the very top, there's a blank, ding, 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 and that block box is blue. And the blue code is typically something that you've obtained in the laboratory. It's not really a calculation. That's normally why I use blue. Now, keep in mind, later on, maybe spreadsheet templates are a little bit different, but I try to keep it consistent. And the blue areas for you and for me are things that should be coming from some type of laboratory data, some type of, in this case, titration volumes that you're gathering, information about labels, information about concentrations. No calculation really that's needed for the blue boxes. So in part A, and I'm going to zoom in just a little bit here. So in part A, what it's going to ask for is something that we call the average tablet weight. And the average tablet weight, we've already talked about a little bit in the kind of the laboratory space maybe, and we abbreviate that as ATW. So with this in mind, I want you to constantly think of manufacturing. So these tablets are not going to have exactly 65 milligrams in them. We know that. It's going to be a little bit less and a little bit more depending on what's there, what's present, what the manufacturing did during that step. Tons of different things that can go on in manufacturing that will deviate that number back and forth a little bit. So when we talk about 65, we're talking about 65 plus or minus a little bit, right? Hopefully that's what we'll see. So a little bit below 65 and a little bit above 65. And for this particular semester, for this particular year, and depending on what we bring to you, it could be different, but most of the time iron supplements are around the same milligram unless it's something specialty, right? So up here at the top, it will say label information, and it says how many milligrams per tablet. And what you're going to key in here is going to be 65. Or whatever shows up on the label that we bring to you for that particular day in the lab. Most of the time it is 65 for these. And again, if it's something different, we will tell you that. So the object here is to determine, does it in fact have 65 milligrams per tablet? Yes or no? So in part A, we get this thing called an average tablet weight. Now, I want you to keep in mind that a tablet is a capsule. A tablet is maybe a hard shell case. It is a pill. Maybe that's what you refer to it as. So this has the 65 milligrams of active ingredient in it. We call this API, active pharmaceutical ingredient, the API. So the API is present plus other stuff. What? Yeah, that's right. Whenever you take a medication, a tablet, a capsule, a soft gel, whatever the case is, there is a very, very, very strong chance that it's going to be the API plus other stuff. And that other stuff are probably things like sugars or binders or colorants or flavors, something that of course makes it taste good, especially in chewables. So these are all of the other things that get added in to the 65 milligrams of iron tablet. And it's going to be blended up and mixed, and then they're going to be pressed into a tablet, and that's what holds the tablet together. That's why it just doesn't poof fall apart into powder in your hand. It's the binders and the other ingredients that allow that process, that manufacturing process, to take place, and for them to end up with some type of hard tablet at the end of this. So what's going to happen is that when we take a capsule and we weigh these in a laboratory environment, these are going to be a very high gram amount or a very high milligram amount, depending on the unit that you're referring to. Meaning that a tablet in this case is going to weigh more than 65 milligrams. I know there's 65 milligrams, at least there should be, per tablet, but more mass is going to get mixed in with that as the binders and the colorants and the things that hold it together, all of those get mixed in, and the tablets are going to end up weighing more than 65 milligrams. That's with everything, folks. Dietary supplements, over-the-counter medication, prescribed medication. That way, these tablets are big enough for you to actually pick up with your fingers and swallow them down the hatch. If not, they're going to be little bitty specks of stuff maybe, and how on earth are you going to grab a pill out of a prescription medication bottle if they're really tiny little bitty things that you can't do anything with, right? So that's part of this process. All right, so the average tablet weight. A lot of times in a proper laboratory procedure, we would take a handful. We would take 10 tablets, 20 tablets. Now, keep in mind, right? These are averages. Statistics is going to be at play. One tablet crushed up is not going to be as good as maybe 20 tablets that are grabbed and crushed up and turned into a powder form. So the more of these, the better off we're going to be. But at some point in time, we're going to waste tablets when we do this. So in real life, these might be 10 or 20 tablets that we're going to measure out. But for our lab kind of experience, we probably started with 5 tablets that we just grabbed out of the bottle. And we put those 5 tablets onto a balance. Now, if you did not do this process, Kim or myself or another laboratory technician probably did that for you. And we are providing that information most of the time on the whiteboard in the lab, so that way that you'll have it. So let's say that I took these 5 tablets and I took a mass, and my mass was 1.940. So I'm going to key in that mass into the spreadsheet. And the next area or box is a peachy color. And that's the color that I often use for calculations. I like for Excel to do the calculation. I don't want you to do this on a calculator and then key the number in. I want Excel to do it for you. So if we had to calculate the average tablet weight, what we've done is that we've got the mass, 1.940, of 5 tablets. So what's the average mass of each tablet, right? I mean, that's what this is all about. So what would happen here is that I'm going to key in equal into the spreadsheet. I want Excel to do a calculation for me. and I'm going to click 1.940 because that is the mass, the total mass of 5 tablets. And then we're going to divide by the number of tablets that we massed. So then when I hit enter, I get 0.388 grams. Keep in mind that the total mass is in gram. So when we calculate average here, that's also going to be in terms of gram. So that's how we calculate average tablet weight. Again, this is something that could have been done for you on the board. You just had to write down that information, and that way you could key this into the spreadsheet when you make it this far. So 1.940 divided by 5.388. Now, the nice thing about making Excel do the calculations for you is that, let's say I'd be like, oh no, shoot, I keyed in 5 tablets and I should have had 7. I made a mistake. Well, I don't have to go back and key in formulas anymore. Let's say that 1.940 was the mass of the 7 tablets, not 5. I made a typo and I need to go back and I need to fix it. Not a big deal. The only thing I have to do is key in 7 there instead of 5, and ta-da! It automatically does the calculation for me, and it updates the spreadsheet. That is the beauty of cross-referencing the cells and making sure that you're clicking areas within the spreadsheet, so that way if you do find a mistake or a typo or a change that has to happen, it will update quite a bit of the spreadsheet for you. So I'm going to go back, I'm going to key in 5 because that's actually what we weighed out when I did it for my purpose. And then 1.940 is what I got when I measured that onto a balance for my purpose. And then we'll take those two numbers and divide them. So the average weight of the tablets are 0.388 grams a piece. Okay? Now, over here to the right-hand side, it says, all right, well, what's the amount of iron in one tablet? Well, we kind of did that from up above, right? I mean, this amount is coming from the label. It is the label claim. That's what we call that, the label information or the label claim. And the label is claiming that 65 milligrams right up here at the top is what is present per tablet. So I hit equal, and then I click the box of D5 because I want to reference to that number, and then I hit enter. So there's 65 milligrams of iron per tablet. At least that's what the label tells me. It's our job to figure if that's going to be the thing or not. Next up, it says, well, what's the amount of iron in a tablet? Isn't that the same thing? Yeah, right up above, it says the same thing. There's no difference. But the weird thing is that the spreadsheet is giving me to do this in gram, not milligram. And I'll explain why in a minute. So in order to convert from milligram to gram, if you've not done that, over here to the side, I'm going to write a note. And that note is 1 gram is 1,000 milligrams. That is a conversion or the relationship between these two things. Millennium is 1,000 years. A whatever it is 1,000 of them. So a milligram, it's going to take 1,000 of them to get to a gram. A millisecond is going to take 1,000 of them to get to a full second. A millicat, it will take 1,000 cats to get to the proper unit of what we would call a cat. These are pieces of the whole unit. So in order to convert this on paper, if I had to show it by hand, I would be like, oh, okay, 65 milligrams over 1. I set my my dimensional analysis up, my conversion unit up, and then I'll bring in the division bar next to that. Milligram on top, milligram needs to go on the bottom, and I'll go to gram on top. What's the relationship here between these two units? There's 1,000 milligrams in a gram, folks. So what would happen is that I would take 65 divided by 1 is 65 times 1, which is still 65, divided by 1,000. That is how I would do this on a calculator by hand and showing the work that needs to go involved here. All right, so within Excel, I want Excel to do this calculation for me. So if I want the amount of iron per tablet, this time in terms of gram, what would happen is that I would hit equal, ding, 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 ding. And then I would click the 65 milligram. So I click that box. That box is now highlighted. And it looks like the only thing I have to do is divide by 1,000. If I want to go from milligram to gram, I take my milligram and divide by 1,000 based on that hand calculation right there. And then I'm going to hit enter. And this will give me the value in terms of gram now instead of milligram. So why would I do that? I mean, what's the whole purpose in getting this into a different unit? Why would I need it a little bit later? Yeah, we will. We'll have to use it a little bit later. So if I look at the next calculation that I want Excel to do for me, this is wanting the percent of iron in the tablet. All right. So here I'm going to go to my little scratch pad if it pulls up. I hope it pulls up. Don't make me a liar, scratch pad. Get it on here. All right. So here we're going to clear this out. I've got this tablet, and this tablet is filled with all kinds of stuff, right? Binders, fillers, colorants, flavorings, the active ingredient, the whole shebang. It's one whole big old package that they press into a capsule or a tablet. Only a portion of this is going to be iron. That is it. Nothing more. I know that it's 65 milligrams, right? 65 milligrams is present due to iron. And then we also have the entire weight of the capsule that we've just calculated an average weight for. So what's going to happen here in this next step is we want the percentage. What percent of iron is going to be found in the average run-of-the-mill tablet that I take out from this bottle? That's why we do average tablet weights. Again, I know some of the tablets are going to weigh less. Some of the tablets are going to weigh more. And that's fine. I just took a handful, random, put them on a balance, got a total mass, divided by the number that I have. It solves all of these wishy-washy problems. Well, not all of them, but a lot of them. So what will happen is that I'm going to convert 65 milligrams into a gram amount. And the reason is because I'm getting ready to divide it by the gram of the average tablet. So on the spreadsheet, if I take a look at this thing, here's the gram of the average tablet that's pulled from the bottle, 0.388. Here is the gram that should be present in every single tablet. So for this particular box, I'm going to hit equal. Ding, ding. I'm going to click the gram of iron that should be present. That is the part of. And I'm going to divide that by the gram of the tablet, which is the average tablet weight, also in terms of gram. They have to be the same unit. Otherwise, this calculation does not work. If one's in gram, the other's got to be in gram. If one's in milligram, that's fine, but the other one better be in milligram as well. So because this is a percentage, if I stop here, it's going to give me a decimal point. I can't have that. I need to talk about percentage here. So whenever we talk about percentage, I'm going to multiply it by 100. So I've taken the portion that should be iron, 65 milligrams. I've divided it by the mass of the entire tablet, which is 388 milligrams. And now I'm going to multiply it by 100. And this gives me 16.75%. So what this means is that when I take one tablet out of this bottle and I put that one tablet into my mouth and I swallow it, 16.75% of the total of that tablet is iron. The rest of it, 84%, give or take a little bit, that 84% is all the other stuff that's not going to do anything for me. It's there in the tablet. It's there in the manufacturing. It's there to keep it together. It's there to make it taste good. It's there to make it pretty. It's there to make it hard. It's there to make it so it stays together and not fall apart. But the other gram, the other milligram portion of this tablet doesn't mean anything. We're not interested in that. So why is this important? We'll talk about this a little bit later in the spreadsheet. But this is how we calculate the percent of iron in each tablet. It is a percent composition calculation in a way. It is the percentage of the iron that's showing up in the tablet divided by the average tablet weight multiplied by 100 in order to get percentage. All right, so part B, keep that in mind. We'll come back to that in just a minute, but that's how we complete part A. For part B, I think this is pretty much straightforward. I'm going to quickly talk about this. Over here to the right-hand side, it says the concentration of the titrant, KMnO4. So this is that purple solution that we used in our burette. That purple solution, based on our lab directions, is close to 0.02, what we call molarity. The capital M stands for molarity, and molarity is just a version of what we would call concentration. How strong is it? I'm not really concerned with the intricacies of molarity or any of these other units yet. This is just a number. We've got to use that number in our calculation. That's what the capital M stands for. That's not the purpose of this class right now. I don't care if you know what molarity stands for or not. That's not going to be the issue here. But keep in mind, that's a unit, like inches or feet or cups or quarts or grams or Fahrenheit. Those are units. That's all that it is. And that unit means strength or concentration. So this is typically going to come from the bottle. Whatever the bottle has on the label, that's what's going to go here. We try to make this as close to 0.02 as possible, but it could be a little different. It could be 0.018, 0.022. I mean, I don't know. But hopefully we'll get close to 0.2 because that's what the lab directions and the method is going to ask for. Over here on the left-hand side, this is the area that you'll key in your burette volume. So this is the point where I have a starting mass or a starting volume, an ending volume, and I go in and I measure out a portion of the tablets because we don't need it all, and I'll talk about why in just a second. But this is the area that I would record all of that information in. All right, so let's say that I follow the lab directions, and the lab directions say, measure out 0.1 to 0.2 grams of your solid powdered tablets. Okay, so let's say that I measured 0.112. That's what I measured out that day in the lab. I wrote that number down on my data sheet. That's the value that goes in here. So it's just the mass of the portion. Now, why did we not use an entire tablet? That's because it's too much, right? One entire tablet is too much for this process to work. I don't need it. So it cannot work. No reason for it. I just need a little bit of smidge, a smidge of active ingredient. That's all that I need. And one tablet crushed up. It doesn't make any sense. There's way too much. I'm going to be wasteful. The titration would work. The titration goes forward. It's just going to take a lot of titrant in order to get that color change to happen. And if we don't need it to go that far and we don't want to be that wasteful, that saves money. It saves reagent. Other people get to use that same reagent. It makes our dollars stretch a little bit further. So I just need a little bitty portion of the tablet. All right, so take a look here, right? If the tablet weighs 0.388 on average, according to my numbers, and again, yours might be different depending on the semester, but 0.388 is what my grams are, and the lab directions tell me to weigh 0.1 to 0.2, that's like 1/3 to 2/3 of the tablet. I don't need an entire tablet to be crushed up and used. I just need a portion of it. The whole thing is way too much. So I'll maybe make this tablet last longer and we can get multiple trials out of it when I powder these down. Next up is the volume where my titration started. So let's say that I go on my burette and I just willy-nilly fill it up to the, maybe not even the top, but toward the top with titrant. This is my KMnO4 purple solution. My start volume is 4, so that's what's going to go here. And then I titrate, drip, 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 and into the solution it goes. Whee! Right? And we wait. And then sooner or later, my sample is going to go pink. And when my sample goes a light pink, I stop the burette. I stop the titration and I say, whoa, Nelly, this is where we end. And I read the volume on the burette and I get 7.4. All right, so I key those values in as well. Notice all of these are blue boxes. So this is laboratory data. That laboratory data is pulled from your measurements or labels off of the reagent bottles. And next is this peach block. And it says, okay, well, what's the total volume for the titration? Like, how many milliliters in total did it take for you to get that pink color? That's what's going to go here in these boxes. So I want Excel to do that calculation for me. So, ding, ding, I go and hit equal. And I know that in order to get this value, I would take my end result, my 7.4, and I subtract my starting amount, and in this example, it's 4 milliliters. You have your own data here. You probably didn't start at 4. You probably started at something different. You didn't end up at 7.4. You ended up at something different. You key in your values here, right? This is just my example. You've got your own lab data to worry about. The process is the same, though. So I take these two volumes and I subtract them. And then I hit enter, and I get 3.4 milliliters that was required for this titration to turn pink, which is where the KMnO4 stopped reacting with the iron because there was no more iron to react with. All right, so I'm going to go in and I'm filling this in for trial number 2 and trial number 3. So let's say that trial number 2, I measured out 0.12 grams. Here I started at the 0 mark on the burette, and I went down to 4 milliliters. All right, so I'm going to type in equal, ding, ding, and I do 4 minus 0 and hit enter. There we go. And then in my third column, I do the same thing. Let's say I weigh out another portion, and the portion that I weighed out here, yet again, was 0.112. I got lucky, right? We're just using the same mass. That can happen. Here on my titrant, I started at 4 milliliters, and I titrated till I got that light pink color, and ended up at 7.5 milliliters. All right, not surprising. So just like before, I hit ding, ding, equal. I do 7.5. That's where I ended. Minus 4, because that's where my titration started. And then I hit enter, and I get 3.5 milliliters based on that titration amount. Okay. All right, so there's part A, referencing the average tablet weight and the percent of iron that is present in the tablet. Part B is the titration piece. So once I put stuff in my burette, I titrated. It looks like I might have refilled it back to the 0 mark, maybe. Okay, that's okay. And then I started at 0 here and went to 4. And then I just picked up with my third titration back at 4, and I continued on to 7.5. Right? It's whatever your numbers ended up being. These are just examples. And I calculated the volume titrant for each one of those rounds so far. All right, so now we're going to go on to part C. And part C is a major calculation here. And it says, hello, this is the equation needed to calculate iron in milligrams per milliliter, and it's blah, 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 right? Okay, that's what that calculation represents. And that's what I want you to tell me. Blah, 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 okay? So I need to calculate in Excel, and I need to use that equation to go by, and I need to key this in the proper way. But, you know, Excel understands the order of operations. That's why it's so great, and that's why we use it all the time. So what's going to happen for me to complete part C, I'm going to go into this box. I'm going to click it, and then guess what? Ding, ding! I'm going to hit equal because I want Excel to do a calculation for me. So what kind of calculation do I want it to do? Okay, well, it starts off with a parentheses, right? So, okay, I'm going to start off with a parentheses as well. I'm going to make it match. And this is what I need to do with Excel. This is why it's lovely. I'm going to click V sub T. And in your lab document, it tells you what V sub T is. V sub T means the volume for the titration. How many mils in total did it take for your titration? Okay. So I click that 3.4. Right there it is. I'm going to click it. And notice it says E21. It references that cell. Okay. And then I multiply because that's what the dot is. So I'm going to go in and key in my asterisks. There's multiplied. M sub T. That is the molarity of your titrant. That's what your lab directions told you that meant. So in the spreadsheet, up here is the molarity of the titrant, and that is my 0.02 number. So I'm just going to click it, and it understands what to do with it. And then I'm going to hit times, because there's a little dot. That means multiplication. And then it gives me this number. This number I'm going to type in. That number is never going to change. It's always going to be 55.895. So then I close the parentheses up. There we go. And that finishes out my top. Next up, it looks like there's a big division line below that, right? Divided by. So on my keyboard, there is a slash. That's for division. It looks like it starts off with a parentheses again. Not a big deal. I start off with parentheses here. That's okay. And then V sub S. V sub S means volume of your sample. So how many milliliters of sample did you prep? And you prepped 25 milliliters in this lab procedure. At least you should have. So we took those little bitty 25 mil volumetric flask, right? And we put everything in that volumetric flask, and that's what we dissolved. So I'm going to key in 25 here, because all of these should have been consistent across the board. They all should have been 25. That number should not be changing. And then it looks like a little dot, so multiply. And then that number is written as 5. It's never going to change with all three of these trials. It doesn't matter. I'm going to key in 5. And now I close my parentheses up. So there's my top portion divided by my bottom portion. I'm going to hit enter here on my keyboard. Ta-da! And there we go. There is the milligram per milliliter concentration based on that calculation, because that's what it tells me, right? I mean, here it says your concentration, if you use this equation, is going to be a number, and that number is milligrams of iron per milliliter of sample. That's what that unit means. That's what this calculation is going to provide. Okay, so now what needs to happen is that I need to do it here, and I need to do it there. So you've got a choice, and I'm going to introduce you to something within Excel. I can go through this motion again. Ding, ding, equal, parentheses, click my volume of the titrant, times my molarity of the titrant, times 55.895, close them up, divided by, open up the parentheses, volume of the sample is 25 times 5. And then I close my parentheses up, and I hit enter, and I get, bing, ding, 0.06. Great, right? It took a little bit of time. I had to key it in again. Not a big deal. That's all right. We can do that. We've got time to do that right now. Why try to make this more complicated than what it should be? Or I can show you a trick. If you're not comfortable with it, don't do it. Key it in like we've been doing, right? But here's the trick. I'm going to delete this out of there. There we go. So if I click on this very first one that we did, we put a lot of work into this, right? If I go up here to the top toolbar, right up here at the top, you can see that on the screen. There's where I keyed in the formula in order for Excel to understand what to do with the calculation. There is something called an anchor. All right. So I'll talk more about anchor in just a second. But an anchor is dollar bill, y'all. All right. So what that means is that if I put a dollar bill in front of the M, and I also have to put a dollar bill in front of the 17. Notice that this M17 is red. And in Excel, I have a red box. And right here it is. And that is in column M and in row 17. So this is M17. If I put a dollar bill in front of M and a dollar bill in front of 17, then this is what we call anchors that value. That means I can copy and paste this formula now, and that value will not shift. That value will not change. that value is anchored in place. So it will always use 0.02 for the calculation. Now, the only thing I have to put dollar bills in front of are sales that I don't want changed. So, for instance, 55.895, that's a number. I keyed in that number. It doesn't reference a sale. I don't need dollar bills there. And then 25 is a number. I keyed that in. It doesn't reference a sale. The 5's a number. It doesn't reference a sale. So I don't need to put dollar bills there, right? Those values are going to stay those values. They're not going to change. There's no option for it at all. But because I clicked 0.02 for this calculation, that 0.02 cell is going to get referenced from here on out. And if I want to copy and paste these things, that can cause me a problem if I do not anchor it. It should always be 0.02. But because it's in a cell in Excel, I don't want that cell to change, so I anchor it in place. All right, so with that said, I'm not going to anchor E21 because that one I do want changed, and I'll show you why. So if I hit enter, notice my number doesn't really change any at all. All right. So if I go back to this cell, and if I want to shortcut this process, I can do that. Right here in the bottom right-hand corner, I see a box. I can click that box. Notice it turns into crosshairs. My cursor does. So I'm going to click my mouse, and it highlights that box, and I'm going to drag it over. Now, in doing that, it's going to take my 3.4, which is what I used first, and it understands that now I want to use the 4, which is right above that. So it makes the shift over on its own, and it uses that number in the calculation. And that saves me some time from typing in this equation all over again. If I drag it over again, and I'm going to, then now it knows, okay, keep dragging over, keep shifting. So now you want me to do the same calculation? Yes. Now you want me to do it with the 3.50, which is right up above it? Yes. But if I do this, that's going to shift. That's a good thing. If I did not anchor the 0.02 value, though, it would have also moved that one. And there's no other numbers out there. It's just 0.02. There's nothing beside of it, and there's nothing beside of that. There's no values that are there. So I have to anchor that in place, and Excel understands, okay, I get it. Now you want me to make the shift over and use this value, but you want me to keep using that value in the calculation. Got it. That's the purpose of anchoring a number. And then it does the same thing. Oh, you want me to move over one more time? Got it. I understand you. I'll use 3.5. I'll copy that equation that you keyed in for the very first time. And this time, I understand that that value has to be anchored. We don't want that 0.02 to change. So hence the dollar bills that were in front of the letter and the number. So this is our way of copying and pasting within Excel, but getting it to update and modify those calculations for me so I don't have to type them in every single time. If I want to type them in every time, then I can do that. And I want you to feel comfortable doing that. That's not a big deal. It's not a problem. But the issue is that I try to limit the work that I'll need to do in the spreadsheet. And this is one of the ways that we do that. Now, I did something deliberately here, and that's because I wanted you to see what the power of copy and paste and stuff is, okay? So here in this formula, I keyed in 55.895. And at first glance, that's what that number looks like, 55.895. But that's not a 9. That is a 4. So there's a mistake here. I don't need to go back and type in the entire calculation again. All right, that's silly. The only thing I have to do is go up here to the toolbar, and that's where I originally keyed in that function. That's where it goes. And I'll be like, oh no, I made a mistake. Let's click right behind that 9 and delete it. Da! And let's type in a 4 there instead. And then I hit enter. Okay, it didn't change my overall number, and that's fine. It's a tiny number. But it allows me to make these really small changes without retyping the entire formula in all over. And again, that's a good thing about Excel. Now, if I go to the cell next door, remember we copied and pasted that. It's already been copied and pasted. I've only changed the first one though. If I click on the second one, notice that 9.5 is still there. So yeah, I'm going to have to change that one too. This is not a cell that it references. It's nothing that's keyed in that it constantly refers to. This is a number, literally a number that's been copied and pasted. So once that gets copied and pasted, there's nothing you can do about it. You're just going to go back and change each one and slightly update those. All right, so there we go. Not a big deal again. You might not be happy with the number of digits that are displaying here. Maybe you want to see an extra increase. Up here at the very top, if I go to Home, and in the Home category, you will see this area here in the center that says Number, zeros that point left and zeros that point right. So I can get the number to extend a decimal place by clicking the arrow to the left. And if I click the arrow to the right, that will shorten the number of decimal places that I would see in a lab. So let's say that someone tells you to report those values with, I don't know, 4 digits after the decimal. There we go. All right. So let's say that looks prim and proper and we feel good about it, and I hit enter. All right. So that makes those changes for those values, and it increases the number of decimal places that show up in the spreadsheet. Next up is line 27. Line 27 says, okay, you just discovered the number of milligrams per milliliter in your sample, but you made 25 milliliters in total. There's that little tiny flask, right? You took it to the line, 25 mils. So this question is, okay, based on that value, how many milligrams of iron would be present in the 25 mils that you prepped? Okay, so the way that we'll solve for this, ding ding, I'll hit equal. I want Excel to do a calculation. If this is how many milligrams there are in 1 milliliter, let's times this by 25 to figure out how many milligrams are in 25 milliliters. There we go. That's all we got to do. Times 25. So this is going to look like it's 0.759 milligrams in my 25 milliliter little bitty sample that I prepped, that I titrated. Again, you can go in and ding ding, and then click the boxes, divide by 25. Ding ding, click the boxes, divided by 20, or times multiply by 25. Multiply by 25. Or I'm going to click the box. I'm going to click the bottom corner. I don't want nothing anchored. I want this to actually move with the data. So as I go over, take the number above, 0.0357, multiply by 25. And then if I go over again, great. Take 0.0313, multiply by 25. I don't need anything anchored there, right? I want it to shift and move with my cursor. So I let go of the mouse, ta-da! And there are my values for the milligrams of iron in the 25 milliliter portion of sample that I've made in the lab before I titrated. Up next, the average. Okay, now this is the average milligram per milliliter concentration. Not the average milligram, but the average milligram per milliliter. That's what that unit says. So that's what I need to take the average of. So ding ding, I need Excel to do a calculation. I type in the word average, just like we've talked about before, open the parentheses up. And now I'm going to highlight that set of data up there at the top. And then I hit enter. Cha-cha! There's the average milligram per mil. Next up is the standard deviation of the values. So, ding ding. Standard deviation, STDEV. Open them up. And then again, I highlight those set of data. And I hit enter. Ta-da! There's my standard deviation. And now my relative standard deviation in terms of percentage. So to calculate relative standard deviation, if you remember, we're going to start off with ding ding equal. Well, standard deviation's at play, so I click the standard deviation number, ta-da! And I divide by the average. That is what relative standard deviation is. Ta-da! I click that. That will give me a decimal point, but this is percent RSD. So because it's percentage, I multiply by 100. And then I hit enter. Ta-da! There we go. 8.85%. Relative standard deviation is something that a laboratory might look at for your precision, of course. That precision, we like for you to be under a certain number. We really like for you to be less than 10% here. So you can see how little bit actually changed, and my percent RSD is already 8.85%. So labs do tighten their belt a little bit on percent RSD, and hopefully your lab data fits within that parameter. All right. Now we're not quite done. So down here at the bottom, part D says percent error. So how far are we? Based on our lab data, we really haven't determined how many is actually in the tablet yet, right? But based on our lab data, what is there and how far off are we? So if I look at the theory percent or the theory amount of iron in the sample in terms of gram, because that's what this unit is. Well, I'm going to go up here to the top and you're going to be like, oh, okay, that's 0.112. No, it's not. 0.112 is the amount gram-wise that the tablet portion weighed plus the iron that you're interested in. And we know that based on our calculations right up here at the top, this is going to be 16.75%. So 16.75% of that number is going to be the actual expected milligrams of iron that should be contained in the sample that I titrated. In other words, this 0.112 is everything, folks. It's everything. Everything that they have mixed into the tablet, that 0.112 is representation of that. I didn't titrate everything in the tablet. I titrated the iron that's present in the tablet. So a smaller portion is actually there gram-wise for iron. And I want to know what that actual number is. And this is where Part D comes into play. So for the theory amount gram-wise of iron in the sample portion, I'm going to click that box. And guess what? You do the sound effect. Ding, ding. There we go. So I'm going to take that. And I'm going to click the starting mass that we used. And the starting mass here was 0.112. Click it. That is the mass. We measured it out. I titrated that amount, but I know that not all of that was iron. Only 16.75% of that was iron. And that's coming from right up here at the top because I just did it. Percent of iron in the tablet, 16.75%. All right, so down here, I'm going to hit equal E17, that is the mass of the tablet, times, and then I'm going to put parentheses here. I like to keep this number together. I don't want Excel to get confused. And up here at the top, I need to times that by 16.75%. So I'm going to click that value, but this is in terms of percentage, and I need it back into a decimal point. So the way that we do that is we divide by 100. And then I close that parentheses up. So 16.75% in terms of a decimal is 0.1675. All right, that's what we're after. So K12 divided by 100. So here I can click enter. Ta-da! There we go. That is the expected amount of milligram or gram of iron that's contained in the portion that I weighed out, 0.112 grams. Again, not all of 0.112 grams is iron. Only 16.75% of it is. Therefore, what really represents iron in that portion is 0.019. Now, I want to continue to do this in the other cells. Again, manually type it in if that's easier for you, or copy and drag it over. But before I copy and drag it over, look at what's happening here. If I go up, I'm going to drag it over. Great. Use 0.12. Absolutely. That's what I want you to do. And then drag it over. Yes, use 0.112. That's exactly what I want you to do. But I don't want the 16.75 to change. Right? I mean, there's no numbers beside of that. When I drag over, I can't drag that over either. That doesn't make any sense. There's no numbers here. I need that 16.75 to actually stay legit and not move. So I've got to anchor that in place. So down here at the bottom, I'm going to click that cell. And then here for K12, that's where that box is at. Dollar bill, y'all. I'm going to put $1 in front of K. And then I'm going to put $1 in front of 12. That way it locks that movement. It does not move. It stays 16.75 every time. And that's great because that's exactly what I want it to do. The others can change, but that one I don't want moved. So I'm going to hit enter just to get it to accept those changes. Notice my answer didn't change. It shouldn't, right? But now what I can do is click the bottom corner, crosshairs, click, drag it over. That moves and shifts. Drag it over again, moves and shifts. It automatically applies that formula to all the numbers up above, and ta-da! There we go. Next up, what's the theory iron in the sample portion? But this time in terms of milligram. Well, I just solved it for gram. If I want this to go into milligram, then we just need a conversion again, right? And if you're not really comfortable with conversion, that's fine. So again, 1 gram is 1,000 milligrams. So here I got 0.019 gram over 1. If I need to show this by hand, gram on top, gram on bottom. Milligram is what we're trying to solve for. Milli means how many? 1,000. All right, so 1,000 goes there. And 1 goes here at the bottom. So it looks like by hand, what would happen is that I would take 0.019 times 1,000. When I divide by 1, it doesn't change the number. I just ignore those whenever they show up, right? So here, the only thing I have to do is ding, ding. There's my get ready for my equation. All right, Excel, I want you to take my gram. I click that number, and I want you to multiply by 1,000, please. And ta-da! There we go, 18.8. Now again, the top number is rounded. And this one, it carried a little bit more digit. It's fine. But that's why it doesn't perfectly match. Now I'm going to click this box. And I don't want to keep typing those in. So I click the crosshairs and shift it over. Yes, I want you to use 0.02. Nothing else really changed. I keyed in 1,000. It's going to keep 1,000 no matter what. And then I copy it over again. Ta-da! And it automatically applies those conversions to those numbers up above. The theory amount, how many milligrams per milliliter would be present. Okay, so how do I calculate this? Keep in mind, this is theory. So what happens here is that, well, okay, 18.8 milligrams is what should be present in your sample. So ding, ding, I'm going to hit equal. I want Excel to do a calculation for me. I want you to take the milligram expected, 18.8, and then I want you to divide, because that's what the unit says, per milliliter. Well, how many milliliters did you prep? You dissolve that 0.112, in my example, in 25 milliliters of solution, right? So this is the way that we get milligram per milliliter. 18.8 grams of iron should be swimming around in that flask. I'm going to divide by 25 because that's the amount of sample that I prepped, and I hit enter and I get 0.751. Folks, same thing. Click in the corner, drag over. The only thing that I did is take the number up above and divide by 25. It's going to do that all the way across. Makes it very easy for me. So we're going to calculate the average concentration in terms of milligram per mil here. So, ding, ding. Average, A-V-E-R-A-G-E. Open them up. And I'm going to average those values out. And then I hit enter. And this is the average concentration of what should be expected if these tablets really did have 65 milligrams in them. That's the answer that we should end up with here. So finally, the calculation here for error. Ding, ding. I want Excel to do a calculation. I open up the parentheses, and it says take your actual amount. What was your actual concentration, right? Well, that's going to come up from above. That's going to come up here where it says Part C, calculation of iron in terms of milligram per milliliter. Well, it looks like that's the 0.032, right? And then we're going to minus the theory, divide it by theory. Ooh, that's going to give me a really bad number, right? Okay, so the issue here is that this is not what this is going to refer to. There's actually a typo that's going to happen here. So this is the average amount of milligram per 25 milliliters. That's what this is going to be, all right, not per mil. So up here at the top, I need a correct for that. It's actually going to reference this number right here. So if I catch this in time, I will make this change within your spreadsheet. If you do not see it get updated within the spreadsheet, then I just go ahead and assume that this is what I want. So what will happen here is that I am going to actually get rid of this calculation for right now. And we are going to go back up here to Part C, and we are going to do an average, not of E6 to G26, but an average of these values instead. And the standard deviation, I need to update that as well. So we'll do an average standard deviation of those values. There we go. And that gives me 0.812. But keep in mind that this is the average concentration of the milligrams of iron in the 25 milliliters of sample that I have. That's the number that we're going to compare to. So again, if I do not make this unit change, I want you to assume that that's what that's for, and that way you can go back and update your numbers and compare it really from apples to apples at this point. I think that will be the easiest than another calculation added on top of what we already have. So down here at the very bottom now, in order to calculate, ding ding, I'm going to hit equal equals my actual value. So my actual value is 0.812. I click on that number, and then I'm going to subtract the theoretical value. If it really does have 65 milligrams in it, this is what should be present in the 25 mils in total. And then I'm going to close those parentheses up. And then I'm going to divide by the theory value again, which is 0.678. And then I multiply by 100 in order to get it in terms of percentage. So once I do that, I'll hit enter, and I get 5.63% error. So what this means is that these tablets are very good. 65 milligrams on the label. Based on my dilution and prep steps, this is the amount that I should end up with, 0.768. What my titration data shows is 0.812, and these two numbers are really close together. So good job if this came from Nature Made. And look at there, you got a little USP logo right there on the front, so you should be doing a good job, or USP would not give you clearance to put their little sticker on it. But that doesn't necessarily go with every single dietary supplement that's out there on the market. All right, so welcome to your first spreadsheet. It took me an hour to go through all the calculations and what goes where and all of that kind of stuff. But at least you were able to follow through, I hope, figure out what numbers go where. A little bit of mishap that's happening right in here on my part. I should have labeled that in a different way. I'll clean that up hopefully by the time you get the spreadsheet. If not, just pretend like this right here that you're seeing right now is what I'm after. So do the average of after you multiply by 25. Do the standard deviation after you multiplied by 25. That way you'll get a comparable number here to what's happening down here at the bottom. Otherwise, we would have had to do an average of something else. Another calculation gets added in, and I just didn't want to take the time for that. I think it could be a little bit more straightforward than that. All right, so hopefully your percent error is going to be really good. We're going to target for something less than 10%. And if so, great job. You did your titration the proper way. And the tablet looks really, really good because of that. So good job, manufacturer. You did your job the right way. And you as a quality control group were able to determine that these tablets are quality. And that's what this course is all about. Now, if you feel very uncomfortable with this spreadsheet, good. And the reason is because I'm pushing you out of your comfort zone and I'm getting you to learn new information, new ways of doing things, new calculations, maybe some new Excel type of work, and that is great. That's why you pay to take a class. You pay it to learn something, you want to take away something that maybe you didn't know in the beginning, and this is one step in that direction. So I don't want you to freak out on me. I don't want you to get bogged down and, oh my God, this spreadsheet's horrible. I don't know what I'm doing. All these calculations. Don't go through that mentality. I think that you will be perfectly fine. Just bear with it. Don't freak out. And the more of these that we'll do, the more comfortable that you'll feel with them. So until I see you in the lab, good luck on your spreadsheets. If you got questions, let me know. I'll be able to guide you. I'll be able to answer some of those questions for you before you turn them in. And whenever you get finished, make sure that you print this spreadsheet out. And then don't forget, up here at the top, go to Formulas. And then Show Formulas. Ta-da! And there we go. It shows me how you've keyed these formulas in to make sure you keyed them in as formulas and not just raw data numbers. Okay? All right, so to get back to that view, you just click Show Formula again. It takes the formulas off, and you can toggle back and forth that way when you go and print these spreadsheets off. There are chances that I might not need the formula sheet. Ask me. If it doesn't deliberately say, just print off the spreadsheet and call it a day. But if it does say print off the spreadsheet and formula sheet, you now know what I'm referring to. All right, guys, so good luck. I'll see you in the lab. We'll probably start a new lab by the time that you see me after this. This will help you with some of those calculations with the iron titration. Again, don't freak out. Don't get worried. The class is not all this, I promise. But it's a part of quality control. And I know it has an ugly face, but we got to take the ugly with the good and the pretty. And this is just one of those things that we got to do. So good luck. Let me know if you got any questions. I'm here for you. That's why I get paid to do the job, to answer your questions and to help you out. So don't feel weird when you need that help.